Is it recording now? Yes. Let's take this problem. So notice this is only just an inductor. I don't have a capacitor there. So I could actually, the math, I'm assuming the math is not going to be that bad. I could be completely wrong. But I'm going to add a twist to it. I want to find V out. Here's where the twist is. I want I sub O to look like this. That's what you do in the lab. You have a square wave. The value of 12 for t between 0 and 1, and 0 otherwise. So the value of I sub O is 12 between 0 and 1. After that is 0. Before that is 0. I mean, to solve this in Laplace again, I need to change this source from time domain to Laplace. I need to change all these to Laplace, solve in Laplace, do the inverse Laplace to get back in time. But how would I change this? What is that function as a function of time? What's that square wave?
12 u sub t minus 1.
I sub O of t, and what is it?
12 u sub t minus 1.
12 u sub t minus 12 u sub t minus 1. Is that what you said, Sam?
Yeah, I missed the first part.
Yep. It should be 12 u sub t minus 12 u sub t minus 1. It's a phase shift. It doesn't start. Basically, what you have is you have this function. That's what u sub t. Add to it that function. This is u sub 12 u sub t. And this is 12 or negative 12 u sub t minus 1. So if you take this, add it to this, notice once you hit this point here, you get a plus 12 here, minus 12, it goes to 0. So let's change everything to S here, S domain. This is 1. I'm just even going to put, I just put a 1. The resistor stays the same. What's the Laplace of 12 u sub t? 12 over S. Minus, what's the Laplace of 12 u sub t minus 1? There's a shift here. This is 12 e to the minus what? S over S. There's a shift in it of e to the minus s. Remember that from math? The inductor, S times L. 1s. The resistor, 1, 2. And this is V out as a function of S. You can see I can simplify this. I can make that a 2.
Are we missing the 6?
Oh yes. Where's that 6 goes? Right here. Good eyes. I missed it. I missed the 6 there. Too early, 8 o'clock in the morning.
It's just the right time for
Yeah. Now notice I can combine this as 2, so I can rewrite that. 12 over S. I'll factor 12 over S. That's 1 minus e to the minus s. Makes it easier to write that way. This will be a 2. This is an S. 6. 1. 2. Again, it's not really that hard, this problem. I just want to show you that step function, that little square wave. You can rewrite that and use this function now. I can use source transformation. This will be a voltage of what? 24 over S. Now, once you do that, this becomes a voltage source. And what happens at 2 ohm? It goes on the top. What can you do with the 2 ohm and the S there? You can combine them, make it 2 plus S. So if you don't want to do 2 equations by 2 unknowns, you keep simplifying.
Are we trying to find V sub O?
V sub out, yes.
So we would just do mesh
You can.
to start right here.
You can do 2 equations by 2 unknowns if you want to, or you can do source transformation one more time there. And combine this with that, the product over the sum. So if you want to do mesh there, I have no problem with mesh. My calculator can solve the mesh. You want to assign currents?
I think it'd be easier to do another one.
Another source transformation?
Yeah, just so you're down to one loop.
You could. You know?
What was the function?
It said
Oh, yeah.
V out. Jake said, should we do just 2 equations by itself? You want to do that? Fine. I was about to do a couple more source transformation, combine them, twist this one again, and go in that direction. But it really doesn't make a difference since my calculator does solve for that. To me, it's not a big deal. So that would be what? That would be a negative 24 over S, 1 minus e to the negative S, plus 2 plus S times I sub 1, plus 6 times the current down, I sub 1 minus I sub 2. Clean it a little bit. 2 and 6 is 8. 8 plus S I sub 1 minus 6 I sub 2 is equal 24 over S times 1 minus e to the negative S. That's equation number 1. Equation number 2. 2 times I sub 2 plus 6 times, I'm traveling this way, I sub 2 minus I sub 1 plus 1 times I sub 2 is equal to 0. 2 and 6, 8. 8 and 1 is what? 9? 9 I sub 2, positive 9. What about I sub S? I sub 1. Negative 6 I sub 1. Actually, do a quick math here. It says 6 I sub 1. That's equation 2. Six I sub 1 equals 9 I sub 2. What's I sub 1 equal to? 1.5 I sub 2. If I know that, plug it in. Go back to equation number 1 and do that substitution. So 8 plus S times 1.5 I sub 2 minus 6 I sub 2 is equal to 24 over S 1 minus e to the negative S. One equation by one unknown. Is that at 12 here? Plus 1.5 S I sub 2 minus 6 I sub 2 12 minus 6 is 6. now to solve for I sub 2, we divide by that. You'll have 24, 1 minus e to the negative s over s times s plus 1.5 s. Oh, not s, that's 6. Divide by that one. I don't like the 1.5 here. So if I factor out 1.5 out of this, if you take a 1.5 out, 1.5 times what is 6? Is that a 4? So you can divide the top and the bottom by 1.5. So 24 divided by 1.5, is that 16? 16, 1 minus e to the minus s over s times 4 plus s. That's I sub 2. Notice the question was, how many questions can you put on the test? I can put a problem like this. We're almost done with it. Didn't take that long. I'm looking for V out. If you know I sub 2, do you know what V out? 2 times that number. So V out as a function of S is going to be 2 times that, which will be what? 32, 1 minus e to the minus s, s plus 4 or 4 plus s, doesn't really matter which one you write first. And now the last thing, I have to take the inverse Laplace. Well, the good news, these are distinct roots. So you can write that as k1 over s plus k2 over what? S plus 4. If I know what k1, k2 are, the problem is over. So let's see if we can find what k1, k2. To get k1 sitting on top of s, we take s out of that. 32, 1 minus e to the negative s over s plus 4 when s equals to 0. When s equals to 0, what's e to the 0? 1. 1 minus 1, 0. 32 times 0 looks like 0. K2, s plus 4, 32, 1 minus e to the negative s over s when s equals negative 4. So put in negative 4. What's 32 divided by negative 4?
Is this you doing partial fraction?
Yeah, well, yeah, that's a shortcut. What's 32 over negative 4? Is that 8?
Yeah.
E to the what?
4.
4. So now I can say V out as a function of S is equal to what? Negative 8, that's a constant, 1 minus e to the 4th, times 1 over s plus 4. And what's the inverse of that? What's V out as a function of time? That's e to the negative what? 40? Yes.
No,
Negative.
it's negative.
Negative 40.
When you're minus,
S
it's
minus
positive.
A.
Plus,
to
yep.
the 18.
When it's minus, it is a plus. When it's a plus, it's a minus. Always the opposite. Be quiet, Sam. There we go. So when you distribute that, what are you going to have? Negative 8 e to the negative 4t. This will be 8 e to the 4. That's just a constant. E to the negative 4t. U sub t.
Could we simplify that to e to the negative 4t plus 4?
And when you multiply, you can add your exponents, absolutely. E to the negative 4t plus 4. If you want to even factor a negative 4 out, so you can write it any way you want to. Here's the negative 4, and this will be what? T minus 1. Because you want to see in terms of that shift, you know? So you get C at T, the 1 second, and this is the original one. T equals 0. Much, much easier for this, and it wasn't really that bad, the math in it. So again, people say, you can't give like 3-4 questions to do on the test. I can make it just an inductor, just a capacitor. When it's only a single inductor, single capacitor, the math itself usually is not that bad. Once you put both them in complicated sources, sine, cosine, where the algebra itself, you start to see like s cubed and s squared and inverse Laplace becomes more challenging. But this was a straightforward.
Yeah, that'd be pretty good.
Yep. Let me try another one. And what made me think about this is Eli, a few minutes ago, he said, you know, at home, I got a capacitor, I don't know what to do with it. I mean, an op amp. We were talking about op amps. Oh, you know what? Let's bring an op amp here. Thanks, Eli. So here we go. I'm not going to give you a source here, but let's put a source. We'll call it Vs as a function of time. That's for any source. This was not my intention till that I heard that comment by Eli. So let me bring in some op amp here for him.
Thank you. You have a big influence on this class.
Did I say all kind of, I meant,
Well,
I meant a resistor. He has a resistor he's having trouble with at home.
and I'm looking for V out of T.
Had a couple
But
wires that are killing me.
let's put a 1 farad here. I did an inductor. I'll do a capacitor here. And I'll put a 1 farad here. Let's say given that circuit. That's not that bad. The good news is I didn't give you what Vs is. So I don't have to find the Laplace of that. I just got Vs as a function of S. So it makes my math easy. And the question, what is V out? Remember, the stuff we learned before doesn't change. Meaning what? The current going in here is equal the current coming out, which is what? 0. And the voltage here equals the voltage there. Well, what's the voltage here? Right there.
0.
Nope. Where is this attached to?
out.
V out. Notice V out is attached right there. So this is really V out. So guess what the voltage here? V out. Because I loop this around. So I can assign current in any direction. Now this one, which way you want it to go? Left or right? You choose. Right? This one.
Right.
Right. This one.
Down.
This one.
Left.
Okay. It doesn't make any difference which direction you make it. So I don't want people to think it's always going this way or that way. You're just guessing. We're not sure what that voltage here is. Nobody knows what that voltage. Let's call it Vx. Let's give them some numbers. This is I1, I2, I3, I4. Again, I'm using Laplace here. Change everything to S domain. Well, the source, since I don't know what the source is, the only thing I can do is V out as a function of S. The resistor stays the same.
Big ol' one.
That, I think that's VS and that's not. Just-
VS, yes, thank you.
Answer the VL.
V out is right there. That's Vs labeled. This is Vx as a function of S. This is 1. Capacitor is what? 1 over SC. C is 1, that's 1 over S. And this is V out as a function of S. And I have 1 here, 1 over SC. C is 1. That's my circuit. The only thing, again, I gotta put the currents in the way we label them. I sub 1, I sub 2, I sub 4, I sub 3. You chose these. And this is V out as a function of S. And the current going in here is 0. The current coming out here is 0. If I do KCL at Vx, KCL at Vx,
Are I2 and I3 the same current?
it will be.
Okay, I just,
Yep.
if there's 0 volts.
Yep, it will be. KCL at Vx. What is going to that node? What current going to it? I see I sub 1 and I see what? I sub 4. And what's leaving that node? I sub 2. And let's write them in terms of the voltages. Notice I sub 1 is going from right to left. You define it right to left. So it's this voltage minus that voltage. Is it hot here? A little bit, huh?
That's my coat.
No, it's hot here.
It's definitely more.
Yep.
in this room.
I get 2 fans in my office downstairs. We just put them together. We can bring them here. So if anyone has some free time, you want to put them together, doesn't take much. Vs minus Vx divided by 1 plus, notice you define I sub 4 is going this way. V out minus Vx. Divided by that, which is 1 over S, equals I sub 2, which is Vx minus V out. I'm just going to write Vx minus V out. I'm tired of putting the S's there. Over 1. Clean that. The good news, these are 1s. So Vs minus Vx. This will be plus SV out minus SVX equals Vx minus V out.
And we're trying to solve for V out.
Correct. Remember, Vs is not really unknown to us. That's your source. Usually you know that is. I just didn't give it to you today. So you have one equation by how many unknowns? 2. So let's combine like terms. Vx and V, when you break it to this side, so we have Vs here, equals, let's look at Vx. You got a 1 plus 2, 2 plus S Vx minus S V out.
forgot the regular V out.
Oh yeah, I forgot that one. S plus 1. Because I'm factoring the minus out. That's equation 1. I need a second equation, and that's KCL at V out, the current in, which is what? I sub 2, should equal the current leaving I sub 3. I sub 2 is Vx minus V out over 1. And I sub 3 is what? V out minus 0 over 1 over S. So you get Vx minus V out equals S V out. Vx equals S plus 1 times V out. And that's your second equation.
Don't you want it to equal 0 because we have the other one equaling Vs?
N equals out. What do you mean 0? Oh, well, I'm going to do a substitution.
Yeah.
I'm just going to use a substitution method. I see what you're saying. Now I know what Vx is. I can go plug it in. I have V out as a function of S. So let's plug it in right here. Vs equals 2 plus S. In place of Vx, let's write S plus 1 V out minus S plus 1 V out. Guess what you're going to have? If you factor S plus 1 V out of each one,
2 plus S minus 1.
which will be what? 1 plus S. 2 plus S minus the 1 is 1 plus S, right? So Vs equals S plus 1 squared times V out. Is that what you got?
S plus 1.
Squared, yep.
Yeah, that's right.
Yep. So what is V out as a function of Vs? V out equals 1 over S plus 1 squared Vs. Let me do the voltage gain, which is V out over Vs. It's an op amp. What's the voltage gain? That's the ratio of V out over Vn. A lot of times we call that AV, the voltage gain in circuits. You have repeated roots. So it's what? K1 over S plus 1 squared plus K2 over S plus 1. Or I don't even have to do that. We know what that is, the inverse, right? What am I thinking? I know what the inverse is. Isn't that the t times e to the minus t?
Oh, yeah.
Yeah.
Yep, I don't even have to break it down. If I did break it down, this would be a 0. But I don't even have to do that. Why would it be 0?
Because you already have something over S.
Yeah, because you're going to take this piece out. You plug it in when s equals negative 1, you end up with the 1. For the second one, you're going to take the derivative of that, which was the derivative 1. 0. So I don't have to do that. That's already in the best form. Yeah, I don't even have to. My mind goes to, oh, repeated roots. Let's write them this way, but I don't have to. So what's this one? That's t e to the minus t. So if you wanted v out as a function of s, it's going to be, just looks silly the way I wrote it. V out equals vs times t e to the minus t.
Did you make up that problem?
Yeah,
Oh,
I just, the only thing I knew that if I made them one, it would make the math easy with capacitors. I don't think it's going to be that,
I know, but
Yep.
usually it doesn't.
yeah, I lucked out here. That's just,
Only when you make one up, it ends up being a.
yep, that was just luck. Yeah, I would love to take credit and tell you I planned for it that way. I did it in my head. Nope. All I knew, if I made the capacitor, if I made these capacitors,
Made up.
they become S on the top. I knew that, and I made it 1, so I don't have to deal with the fraction.
You're gonna make them that nice for us? I'm gonna do it.
Well, probably not.
Will there be op amps on that exam?
I mean, you saw that. You better hope there's op amp, because it looks like it makes the math a little bit easier, the problem easier.
Yeah, that really would be, not bad.
Yep.
That's because the numbers were
Thanks,
simple.
thanks so much.
Yeah, I think because you're removing some current, or at least because we only have, I don't know, it just seems like. That's the first
I mean,
time.
it was easy because our V out was the same as the voltage, like.
Well, two of our currents were the same too.
Yeah.
Yeah, I made them the same, because I'm trying to take the easy way out. Now, if I put a capacitor and inductor, then the math gets a little bit tougher there. Again, the part I keep looking, I didn't see our book does any of these examples, is if you have initial conditions. And if you have an initial condition, just a quick reminder, where is it? I have that page in our book here. If you have an initial condition for that capacitor or the inductor, then you can't neglect that. All the problems we did, the initial condition was 0, so the inductor becomes SL. But if it's not, then you gotta either use this or that circuit. It depends which one makes the problem easier. It's up to you. If the capacitor, if you have an initial condition, V0 is not 0, you can either use this one or that one to replace the capacitor with. Otherwise, if the initial conditions are 0, 1 over SC. All these problems, our initial conditions were 0.
Wait, so you have to replace it with a source?
You replace it, yep, this or that. This or that. That's because the derivative, the Laplace of the derivative is this. That's the Laplace of the integral. Remember, V equals L di dt, right?
Yeah.
For inductor. And the Laplace of the derivative, you end up with that extra piece. L di dt, S I sub 0 minus or plus I sub 0. When you have an integral, the current is 1 over L, the integral of V dt. So that's why you have to do the Laplace of the integral, you end up with that one. And I was looking, I get, just to see if the book I have with me has any examples.
And what's the value of our source for that? I can't tell what that is.
This is I sub L or V0. I'll show it. Let me see if I can find an example.
Did you try the old book on the website?
You know what? I'll make one. Uh-oh. I'll make one. Because I really don't see one, so I'll make one. I'll make it simple enough. How's that? How much time we have? Yep, we got a few more minutes. So let me take one, and I'll put just one of them in. I could put two, but I'll just put one.
So in these kind of problems, there's going to be a switch, right?
Yes. What do you want to use? 60 volts here?
Wait, why would we use- Oh, to make it actually use that.
And now we have
Catching things up.
10K.
We have this patch this guy.
Yeah. We're doing these kind of problems now.
And where?
Physics. But like a long way.
Let's say we have a capacitor here.
The way that they don't need to be done.
We should use Laplace on this test.
One.
Honestly, you can use phasor.
He probably will know it, trust me.
Do you think I could use phasor instead? Oh, that's a good point too.
This is really a
I
simple,
guess you could, but
this is just a simple circuit.
Could use Laplace.
And this is 3 kilo ohm.
We actually have, I think, the same problem on the other side.
And let's say the switch is going to go from this end to that end at t equals to 0. And the question is, can you tell me what the current through that 3K resistor? Find I. Just to show you how you use these initial conditions. So I have to look at the circuit for t less than 0. So for t less than 0, this is what my circuit looks like. And assuming it's been sitting there for a while, the switch is connected to the capacitor. That's what the circuit looks like.
you won't hit the 3K ohms because
Nope.
that's passive.
That switch is not even connected. But what's going to happen if you let it sit for a while, what happens? This is a DC source. How does the capacitor behave to DC? Open circuit. So your circuit will look like this if you're looking at it. And I'm looking for this voltage. That's V of 0. So what is the voltage at 0? I heard that. Somebody said it a few minutes ago. 60 volts, yes. Now we're going to look at the circuit for t greater than 0. Again, this is circuits 1. Remember that? We're going to do it with Laplace. For t greater than 0, this is what the circuit is going to look like. And this is really no factor on that circuit. This is I here. So this is for t greater than 0 now. So I can even skip this part here and just leave that part. So I have 1 microfarad. $3K. And I want to use Laplace for that. Where is our book? This is our book. It says if you have a capacitor, I'll read to you in case you can't see it there, you can replace it with the capacitor of the value 1 over SC plus to minus the voltage is 0 divided by S. My voltage is 0 of the capacitor is what? 60? That would be plus to minus 60 over S. Or I can replace it, if I'm looking for the current here, I can replace it with SC here, because I equals V over this, with a current source pointing upward, the value C times V of 0. So I'll use this because that'll give me one loop. Actually, I can find the current through it. So I'll use that circuit. So I'm going to take the capacitor now and replace it with 1 over SC. I should have made my life easy and just use 1 and 3 instead of 1 micro and 3.
You could switch it to 3 micro.
Well, I'll just leave it. 1 over, what's 1 over 1 micro? 1 million over S. M for million, mega. A voltage source here, plus to minus, of the initial condition, which is 60 divided by 0. By S, V0, that's V0 over S. So again, this is V of 0 over S. This is 1 over SC. And this is 3K here. And you want to find that current right there. Notice these problems, they were a nightmare in circuits 1. They're really not bad now. It's only one loop. That's it. Minus 60 over S, if I do KVL here. Minus 60 over S plus 1 million over S times I plus 3,000 times I is equal to 0. I will make life easy by multiplying every single term by S. And if I multiply every single term by S, what are you going to have? Negative 60 plus what? 1 million I plus what? 3,000 S times I is equal to 0. 60 equals 1 million. This is the type of question I make, huh? Where the numbers are crazy. What's I equal to? But the math ends up being really simple. 3,000 S plus 1 million. Now I don't like this. I'm going to factor out 3,000 so I can simplify it. Bless you. What's that, 1,000 over 3?
Yes.
What is 60 over 300?
1 over 50.
1 over 50, is it?
0.2.
60 divided by 3,000. 0.02. Yeah, 150, right? 0.02 times 1 over S plus, that's I as a function of S. Can we change this to I as a function of time? Boy, I'm on a roll today with all these nice problems. 0.02
It's Laplace.
e to the negative 1,000 over 3t. U sub t, for this is for t greater than 0. That gives you an idea why engineers like Laplace. Again, I'm not saying every problem we do, the math is going to be nice and easy. In some cases, the math is really ugly. You go, oh boy, what did I get myself into? Let's see if I can find one here quickly. And maybe I'll cheat and I'll just use, if there's one in the book, I can use their numbers and plug them in. I'll try, I like when the book does it like in 4 steps.
E to the negative 1,000 over 3t. 3 essentially gonna be 0?
Well, it depends when you look at it. So if you look at milliseconds,
Oh,
you right? Because the only source you have there is the capacitor. The capacitor was charged to 60 volts. So what's going to happen there, the capacitor is going to discharge, right? And how fast is it going to take? Well, 5 times that number, 5 times that number will go to 0 almost. So do 5 times that number. It's not much really time, just for a microsecond, a few microseconds. That capacitor, initially that capacitor has a value of what? 60 volts here.
so that's gonna
Voltage.
pretty much like instantly go to 0.
Yep, like in human eyes, yes. If it's a computer machine where the speed of that in microsecond or nanosecond, that seems like days. You know, because that's not really that much of a small number. You go, well, you know, that's a small number, but not compared to when you're dealing with nanoseconds and microseconds. But a human, yes, you won't even notice. By the time you go to measure it, you grab the probe, you plug it in, it's already fully discharged. You know, it's gone. If you have a big capacitor, like if you have a TV, one of those Samsonite giant screen TV, they have these big capacitor on them, and you're supposed to wait a few minutes before they discharge, because God help you if you go and touch it while just unplugged there, you will zap yourself and you will feel it. I'm speaking of experience, because I've done that. Like, it's not like quickly, it doesn't discharge that quick there. Got to give it a few minutes to discharge. I go to,
Does TVs have like some like static charge always on there?
well, there's some, yeah, every time your body has static
Like
charge on it too.
drain?
Yeah. But though those capacitors, I go to take that capacitor out to take some screws out, and my screwdriver head that goes pop, and you can feel like, uh-oh, I had to replace something in the board there quickly. Let's take this problem, and I don't know if I have time to finish it. We got like 5 minutes, yeah, or 7 minutes, good luck. But we'll just set it up at least, just to show it's not always going to be a nice, pretty one. This is for t greater than 0. I'm not giving an initial condition here. I didn't do any actually dependent sources, right? Okay.
That could be fun.
Well, let's change this one so I can steal the answers. I'll change the value, 0.1 e to the negative 3t. Because I know I don't have any time to finish this. This is a 100 ohm resistor. This is a capacitor of a value of 1 over 7. This is an inductor of 6 Henry. This is another capacitor of 1 over 2 F. And we have a dependent source here. It is a current source, and the value for it is 0.2 times V2 of t. And V2, in case you're wondering, is the voltage right here. This is V2, and this is V3.
Just V1.
V1 is this. Oh, you know what? This is a current source here. That's a current source. This is V1. And the question, find V1, V2, and V3. The only assumption, initial conditions are 0. Just to make math a little bit easy. Assume
Is that V of 2 for
V,
dependent? Or
yes, V2. Yeah. Assume the voltage across all these capacitors are 0, and the current through the inductor, I sub L, at 0 is 0. No initial conditions. So I got to change everything to Laplace now. What's the Laplace of 4, or 0.1, not 4, 0.1 e to the minus 3t? 0.1 over, is it s plus 3? Is that the Laplace of that?
Yes.
The resistor stays the same, 100. Again, this is V1 as a function of S, capital V1. This is V2. This is 1 over SC. 1 over SC, 7 over S. This is SL. 6S. This is 1 over SC. 2 over S. And this is V3. And the dependent source, again, we don't know what V2, it becomes 0.2 times V sub 2 as a function of S.
Now we just do mesh for this.
Well, you can do measure, you can do null analysis too. Because if you look at that current going in here, should equal this current, right? So I can say that's my first equation.
You can do source transformation.
I could, yep.
You can't do mesh because you got a,
Current, so well, you know what the value of that current.
yeah.
If you do a mesh, this current will be 0.1 over S plus 3. So you only have two equations by two unknowns.
You got two
That's not
sources.
the worst.
Yeah, you can do source transformation, yes, simplify. Or if I do KCL, the current going in equals the current leaving. What's leaving? V1 minus V2 over 100.
With source transformation would be real easy, because then we'd have.
Can't do source transformation here. That's the current source.
Oh, yeah.
I forgot that's the current. Initially I had a voltage, but you can't. Yep.
You do source transformation that way, with that other current source.
This one here, you want to do source, you can do source transformation there, yep. But that's the first equation. You can clean it. If I multiply by 100, by the way, just to clean it, what would you have? 10 over S plus 3 equals V1 minus V2. That's one equation. Let me define current here. I'm just quickly. I can define current going that way. We did KVL before we do KCL here. Let's do KCL and node V2. So this was KCL at V1. Let's do KCL at V2. What is going to that? That's this current, which is V1 minus V2 over 100 equals the current leaving, V2 minus 0. V2, not V out. There's no V out. V2 minus 0 over what? 7 over S plus V2 minus V3 over 6S. Six and 7, 42.
Okay, then we got.
I can bring the S up there. S times V2 over 7 plus V2 minus V3 over what? 6S. What's my LCD? 6 times 7, is that 42? 4200S. So you'll have what? 42S times V1 minus V2 equals, is that 600S? squared V2. S cancels the S. Is that 700? Again, I'm going through it quickly. Hopefully I don't make a math mistake there. And you can take this and rewrite that in a nicer way. I have V1, V2, and V3. V1, if I bring everything to one side, that's negative 42S. V2, if I bring to this side, becomes a plus. That'll be what? 600S squared plus 42S plus 700 V2. And what about the V3? Is that negative 700? And that's equal to 0. And that's my equation number 2.
It's gonna be a 3 by 3.
Yep. If I did that, it would be 2 by 2 because I know what that current. And let's look at the last one. Let's define current coming down this way. KCL at V3. What do we have? We have V2 minus V3 over 6S equals the current leaving V3 minus nothing, V3 over 2 over S plus 0.2 times V2. That'll be S
Isn't it 2
0.2. V2 as a function of S, not times S. That means a function of S. Is that what you mean here?
Yeah.
That's a function of S. Yeah. So that would be V2 minus V3 over 6S equals S V3 over 2 plus 0.2 VS. What's my 0.2 V2. What's my LCD? 6S V2 minus V3 equals 6S, that's 3S squared, V3, 0.2 times 6, which is what, 1.2? And again, collect like terms. There is no V1. V2, what do we have? If I bring this one to this side, it will be plus 1.2S minus 1 V2, and V3 will be what? 3S squared plus 1 V3 equals to 0. And that's my equation 3. 3 equations by 3 unknowns. What time is it? Oh, we passed, way past. So quickly, you can push these on your calculator, push the button. You end up with these. V1 as a function of S is going to be 3 times ugly, ugly, ugly. The bottom, S plus 3.
We can plug this into our calculator. and
Yep, 3 equations by 3 unknowns.
Yeah, I'm doing it right now.
30,
Please, already got
Yeah.
S cubed
I wanna see if I actually get the right answers also.
plus 45S plus 14, the top 100 S cubed plus 7S squared plus 150S plus the 49. And you can do V2 as a function of S. It's 7 times S plus 3
Read the same volume.
30s cubed plus 45s
I gotta switch to
plus the 14
exact.
over, at the top will be 3s squared
If you don't switch to exact,
plus 1
getting fractions and S squared plus something.
V3 negative 1.4
Not good.
S cubed here.
It looks like I have it to another column.
Again, double check these on your calculator there. And now, once you get this, you got to find the inverse Laplace.
I'm pretty sure they equal the same thing.
What'd you get?
I got like 900 times S to the fourth plus 63 S to the third plus the
I'll just give you quickly the inverse Laplace, V1 as a function of time. Good luck. Breaking this one down. 9.789. Make sure you have a long piece of paper.
3 plus
E to the negative 3t. So this example was really ugly regardless how you did it. Plus 0.0617 e to the
a
minus
lot of it looks the same, but yeah,
0.294t
I'm gonna be so mad when it comes up on the test and I write down the wrong thing.
plus
Just trying to
0.148
type it.
or 149
Well, I'm gonna write it down how it says right here. I've yet to be right as compared to that.
cosine
So you do the same thing.
1.25t
Because I normally have a power higher, so I'm gonna have S to the fourth or something.
plus
Well, that was 90 S to the fourth plus 105 plus.
0.517 e to the negative
That one.
0.147t sine 1.25t. You can go to Mathematica and plug it in. That's just V1.
Is that really the book answer?
Yep. I'm sure it's all Mathematica.
Oh my god.
Then you-
Simple labs, where we go.
Then you do V2 and V3.
Simple lab.
Are we showing like picture, like in the book
Copy and paste
solutions?
from WebAssign.